Good morning. Today we are going to discuss something regarding geometric properties of sections. Before that, we have already had some information regarding geometric properties of sections. In the previous class, we have discussed various concepts, and in today's class, we are going to discuss the problems about that. And let us once brush up the previous sessions topics. So first we have discussed center of gravity, right? So the center of gravity is nothing but the point at which the whole weight of the body is supposed to act is called as center of gravity. Next, we have discussed center of mass, the point at which the whole mass of the body is supposed to act is called the center of mass. Next, we have also discussed centroid. So, centroid is nothing but the centroid is defined as that point where the whole area of the figure is said to be concentrated. So, we have also discussed centroid for simple plane geometric figures such as rectangle. So, for rectangle, it is simply the center of gravity is if B is its base and D is its depth, then B by 2 comma D by 2 is the center of gravity. Next, for a square, the center of gravity is if A is the side of the square, then its center of gravity is simply along the x and y coordinates as a by 2 comma a by 2. Next, for a triangle, it is b by 2 comma h by 3, where b is the base and h is the height of the triangle. Next, for a right angle triangle, it is b by 3 and h by 3 from the base. Next, for a circle, it is simply the d by 2 comma d by 2. Next, for semicircle, it was d by 2 comma 4r by 3 pi. Next, for quadrant, it was 4r by 3 pi comma 4r by 3 pi. Next, for trapezium, we know that the center of gravity is at the x-axis. Uh, it is simply b by 2, and at the y-axis it is h by 3 into 2a plus b by a plus b. So we also found center of gravity of some simple solids like the right circular cone, which is symmetric about x-axis. So about y-axis. So there the y term is simply h by 4. And similarly for the cylinder also, the y term is h by 2. Next, for the hemisphere, the y term is 4r by 3r by 8. So we also found that by the method of movements, how can we calculate the centroid of complex figures? So for whenever a complex figure is given, first we need to divide that complex figure into simple definite sections such as squares or rectangles, triangles, etc. We have to determine it in a definite shape, and then we have to find the distances from the x-axis and distances from the y-axis, and also their area of each section, each definite section. Next, what we need to do, what we just need to find the areas of the sections. Then the center of gravity of that body was simply taken as x bar is equal to a1 x1 plus a2 x2 plus a3 x3 and so on by a1 plus a2 plus a3 and so on, right? So like that we have to take the x coordinate, and similarly for the y coordinate it is a1 y1 plus a2 y2 plus a3 y3 plus and so on by a1 plus a2 plus a3 plus and so on. Okay. So in this manner we'll be finding the x coordinate and y coordinate. That is nothing but the centroid of the given figure, right? So next, in today's class, we have also found the centroid for simple T section and I section and so on. And in today's class, we will have a forward step by solving few more problems to find out the centroid. Okay. So now see this. Find the centroid of the area given here in the figure A. 1a. So you can see that there are, it is something like a front view of a piston in a cylinder, right? So piston in a cylinder. Okay. So now you can see there are two rectangles. So one is a big one, that is this one, and above that you have one more rectangle. So the first rectangle is of length 34 and width is 40, whereas the second rectangle is of length 50 and the width is 80. And in the first rectangle you can see a space, a hollow space of 26 by 18 dimensions. So now you need to find the centroid of this entire section. So we already discussed in the previous class how to find the centroid for a given composite figure. So in this, first if we divide this problem into definite shapes, so you can have the only one shape, that is rectangle. So first rectangle is of the dimensions 34 by 40. So area A1 is 34 into 40. Next, second rectangle is a hollow space, that is of area 26 into 80. Next, third rectangle is of area 50 into 8. So these are the three rectangles. So whose areas are A1, A2 and A3. So we'll make use of those dimensions and we find like that. Next, so if you see, this is symmetric about y-axis. So the x term is same everywhere. So now if I take symmetricity about x-axis, then it is not symmetric about x-axis. So now what all we should do is, so let us find the distance from the x-axis. From certain x-axis we are finding. So from the base I am taking. So from this base, from baseline, centroid of the first figure is, it is simply, see, if I take something line along the base. So from the base, centroid of the section 1 is simply 20. So y1 is equal to 20 because it is 40, and we know that for the rectangle it is simply b by 2 and h by 2. So it is h by 2, it is 40 by 2. So along it is 40 by 2, it is nothing but 20. Again for the second section, if you see, so the center of this section lies about a distance of, from the baseline, if you see, so from this baseline to that second section it is 4 4 mm, and from this 4 mm, if you take half of this rectangle, it is simply 18 by 2. So 18 by 2 means 9. 9 plus 4 is 13. So y2 is equal to 13. Okay. So like that you have to find. Now for the third section. See, this third section is at a distance of 40. And we know that the formula for this to find centroid is h by 2. So 8 by 2 plus the distance from this axis is 40. So 40 plus 8 by 2, it is simply 44. So its center is at 44. Okay, so like that we found y1 is 20, y2 is 30, and y3 is 44. So next, so this is what we have discussed. The given area is symmetric about the vertical axis yy. So our x bar lies on that axis. Now we need to divide that section. We have already divided. That is 1, 2 and 3. 1 and 3 are the rectangles and 2 is the hollow section. Hollow section. Right? Next. Next, so we have already calculated this table for centroid, and now we will take so area of the centroids. Let us take. So we have three sections, out of which two are the composite sections, and the third one is of which has to be removed part. It is a hollow section that to be removed. So for the first one, we know that for the first section, its length is 40, its breadth is 40, and the length is 34. So 40 into 34 is 1360. So we know that its centroid is at a distance of 20 from the base. So now area into that y term, nothing but 1360 into 20. It will give us 27200. Next, so the next section, second section, which is to be removed off. So we have to take minus for that. So it is 18 into 26. So it is 468. So I will take minus 468 because it is a hollow section, that portion has to be removed. So and it is at a distance of 13. 13 is the centroid for that particular figure. Now A into Y, area into that vertical distance is 468 into 13. So that will give you minus 6084. Next, so area is 50 into 8, the topmost section. It is 400. So y is equal to 44. So A into y is equal to 44 into 400. It is simply 17,600. So you can write now sum of that area in nothing but A1 minus A2 plus A3. So 1360 minus 468 plus 400, that is equal to 1292. Next, sum of the summation of the AY. So A1 Y1 minus A2 Y2 plus A3 Y3, that is equal to 27,200 minus 6084 plus 17,600. So that will give you a value of 38,760. We know that the formula for the centroid of composite sections is a1 y1 plus a2 y2 plus a3 y3 and so on by a1 plus a2 plus a3 and so on. That will give you the y bar. So y bar is equal to 38716 by 1292, that is equal to 29.96 mm. So our centroid lies at 29.96 mm from the baseline. Okay, so this is how we'll we will get. So the centroid is simply 0, 29.96 mm. Next problem. So determine centroid of the following area. See, you can see in this particular figure, you can assume three areas. One is a right angled triangle. The second one is a square. And the third one is a semicircle. So a right angle triangle which is of base 100 and its height is 100, and a square which is of side a rectangle which is of length 120 and height 100, and a semicircle of diameter 80. Okay, so this is how the problem is given. Now we need to divide these sections. So let us divide these sections first now itself. So first section 1 is the triangle. So its base B is 100 and its height h is 100. So half BH is the area of this triangle. Now half into base is 100 into height is 100. So you will get about 5000 of 5000 value of area. Next, so you can see the rectangle. The rectangle base is 120 and its height is 100. So the area is 120 by 100. So you will get 12,000 area. So that is your third section. Next, the section which has to be removed, that removable part is, so that is semicircle. We know that area of the circle is pi r square. Now half of that circle means pi r square by 2. So pi into uh, 40 square by 2. You will get the area of this section 2. And here also, see here 1 and 3 are the shapes that to be kept, whereas 2 is the space that has to be removed. 2 is the region that has to be removed and made a hole. Okay, so here also you have to take like a1 y1 plus a1 y1 minus a2 y2 plus a3 y3 by a1 plus a1 minus a2 plus a3. Okay, that is what. So let us divide the shape into three sections. This is what the first step of our problems related to composite figures is given. So divide this given shape into three parts. That is portion 1. It is a right angle triangle whose base is 80 and whose height is 100. Next, the portion second one, that is nothing but the half circle. The portion that is needed to be removed, it is of radius 40. Next, third portion, that is rectangle. So the rectangle is of length 120 and its height is of 100. So now we know that area of a triangle is half BH. So it is simply half into 80 into 100, that is equal to 4000. Next is the horizontal so it is area 1 by 2 into 80 into 100, that is 4000. Next, the horizontal term would be uh, the centroid is, for a right angle triangle is 2 by 3 into b, b and h by 3. 2b by 3 and h by 3. So here the 2b by 3 means 2 into 80 by 3. It is nothing but 53.3. Next, uh, so now A1 X1 nothing but 4000 into 53.34. So that will give you value of 2,13,360. Next, y value is h by 3. So nothing but 100 by 3. It is simply 33.34. Now A1 y1 is 4000 into 33.34. Next, second one is the area which to be removed, semicircle. So that one will take minus because we have to take that amount of difference from the given value. So it is pi d square by 2, right? So generally we have for the circle it is pi d square. Now here we have to take half of the circle because it is a semicircle. So pi by pi d square by 2. So it is simply pi into 40 pi d square by 4 or pi r square by 2. So pi r square by 2 means pi into 40 square by 2 and the x term would be 140 and the y term and then area into the x term is minus 2512 into 140. So you will get minus 351680 pi. Next, the y term is simply 4 into h by 3. It is 4 into 40 by 3. This 4r by 3 pi. It is simply 16.985. Now area into y term is 42666.32. Next, the third section is a rectangle. So it is 120 into 100. Area is L into B. So the area would be 12,000. Next, the x term is, so actually you have to take half of that, but from the base we are taking, so it is 140. So it is simply 168 triple double zero double zero is area into x term. This 12,000 into 140. Nothing but 16 lakhs 80,000. Next, y term is 50. Now a1 y1 a into y is 50 into 12,000. That's nothing but 6 lakhs. Okay. Now summation of the areas. It is nothing but 4,000 minus 250,2512 plus 12,000. So it will give an about value of 13,488. Next, x value is a1 x1 plus minus a2 x2 plus a3 x3 value is 15 lakhs 41,680 mm square. Next, the y value is sum of the a1 y1 plus minus a2 y2 plus a3 y3 is 6,90,693.6. So this is how you will find the you'll calculate the part. Now x bar is simply a1 x1 minus a2 x2 plus a3 x3 by a1 minus a2 plus a3. So it is simply 15 lakhs 41,680 by 13,488. Next, the y term would be a1 y1 minus a2 y2 plus a3 y3 by a1 minus a2 plus a3. It is simply lakhs 90,693.6 by 13,488. Okay, so that is what. So the centroid can be written as like this, that whatever I have told. So x bar is simply summation of ax by summation of a. So it is 15,41,680 by 13,488. So it is simply 114.3 mm. Next, y bar is sum of a y by sum of a. So a1 y1 minus a2 y2 plus a3 y3 by a1 minus a2 plus a3. So it is simply 51.2 mm. Okay. Now let us see this. Let locate the centroid of the composite figure shown in the figure 3 with respect to the x and y axis. So you can see the x and y axis given. So here you can see a different shape of one rectangle, one right angle triangle and one semicircle. So the rectangle is of shape 15 height and the base is 30. Okay. Next, the right angle triangle is of height 15 and its base is 30. And one more semicircle of diameter 15. Sorry, radius 15. So we need to calculate from this baseline. Okay. So from the baseline, if you see first area of this rectangle is L into B. So you can take 15 into 30. It is nothing but 45 for 450. Okay, 450 is the area of this rectangle. Next, area of this triangle will be asked. That is half BH. So half into 15 into 30. It is 225. Next, area of this semicircle will be asked. That is nothing but pi r square. So pi into 15 square. Okay. So in this manner will be asked. So it is 225 pi. Next, so for this rectangle, the centroid is located at b by 2 comma h by 2, nothing but 30 by 2. It is 15 by 2 and here 15 by 2. So it is simply 15 comma 7.5. So the x term is 15 and the y term is 7.5 here. So here at the center it is 7.5 and it is 15. Next, for the rectangle triangle, it is simply 2b by 3 and h by 3. Okay. So 2b by 3 means 2 into 30 by 3 and 15 by 3. That will be for a rectangle. Next, for this, it is along the vertical axis it is simply d by 2 and along the horizontal axis it is 30 plus 4r by 3 pi. Okay, 30 plus 4r by 3 pi. So that will be its centroid. So let us see. Okay, so for the given problem you just divide the composite area into rectangle, triangle and semicircle. So first portion is a rectangle, at the base it is there and above that rectangle it is a triangle. Now beside the triangle it is semicircle. Semicircle. Above that is a semicircle. Okay. So now here, so for the rectangle the area is 30 by 15. So 30 into 15, it is 450. Now we know that the centroid for a rectangle is b by 2 and h by 2, and below or beside that no other figure is there in between the axis and the rectangle. It means both the x-axis and y-axis lie on the are the rectangle is placed on both the axes. So on the x-axis it is b by 2, nothing but 30 by 2, it is 15. Next on the y-axis it is 15 by 2, nothing but 7.5. Now a1 x1 is 450 into 15, nothing but 6750. Next, at the y-axis it is 450 into 7.5. It is nothing but 3375. Next, area of the triangle is half BH. Nothing but half into 30 into 50. So it is simply 225 square mm square. Next, now for this the x term is simply for 20 is nothing but 2b by 3. Okay, so 2b by 3 is the formula, so it is 40. Next the y term is, it is h by 3 plus at the base there is a height of 15, so 15 plus h by 3, so that you will get the value of 20, right? So 15 1 5 plus h by 3 is nothing but 15 by 3, so 15 by 3 is 5 and 15 plus 5 is 20, so it will give the a into y nothing but 20 into 225 is 4500. Next, so area of the semicircle is pi r square by 2. Okay, so this is also you have to remove the material, so uh, this is again uh, sorry, here we are not going to remove the material because here no hollow space is there, everything entire region you have to find. So it is pi r square by 2, so it is equal to 353.25 mm square. Next the horizontal term is again, so how to take the horizontal term, it is 30 plus 4 into r by 3 pi. Okay? So 30 plus 4r by 3 pi, because it is at a distance of 30 from the y-axis. So 30 plus 4r by 3 pi, that will give you a value of 36.36. Next, a into x, nothing but 353.25 into 36.36. So you'll get a value of 12,847.359. Okay, 12,847.359. Next, at the y term, it is simply 15. Okay, it is simply 15, nothing but d by 2. Okay, so it is at a distance d by 2, nothing but 15, 30 by 2, it is 15. Now area into that y term, nothing but 353.25 into 15, it will give 5298.78. So now summation of the areas, nothing but a1 plus a2 plus a3, that is 450 plus 225 plus 353.25. So this will give you a value of 1028.25. Next, summation of the moments, moments of areas, that is a1 x1 plus a2 x2 plus a3 x3, that is equal to 6750 plus 4500 plus 12,847.359. So that will give you a value of 24,097.349 359. Okay. Next, y term. Similarly, moment of summation of the moment of areas of along the y-axis about the x-axis. So it is 3375 plus 4500 plus 5298.78. Okay. So this entirely will give a value of 13,173.75. Okay. So now position of the x-axis and y-axis. So we know that x bar centroid about the y-axis is nothing but x bar. X coordinate is a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Right? So it is 24,097.349 by 1028.25. So it will give you a value of 23.45 mm. So now the x coordinate of the centroid is 23.45 mm. Next, position centroid from OYX from x-axis is y bar is equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. So that is equal to 13,173.75 by 1028.25. So that is equal to 12.81 mm. So in this manner we will find centroid positions of the centroids. Okay. Next, the fourth problem. So determine the centroid of the given portion of a semicircle area which is removed from a trapezium. So you can see a trapezium there which is having of two unequal sides 40 and 60, and its base is of 80, and from this a portion is removed, that is a semicircle of diameter 40. So the leftover portions centroid has to be found out. So we know that the first step is to divide the given area into the definite standard sections. So now we are dividing this section into standard three sections. That is, the trapezium is divided into two sections. One is a rectangle and the other is a right angled triangle. So the rectangle dimensions are 40 and 80. So 80 into 40 is the dimension of the dimensions of the rectangle. So it is simply L into B, it is 80 into 40, it is 3200. Now the x term of this rectangle, x and y coordinates of the rectangle are given already. Now the centroids of this particular rectangle is simply L by 2 and B by 2, nothing but 80 by 2. X1 is 80 by 2, that is 40, and y1 is 40 by 2, that is 20. So x1 comma y1 are 40 comma 20, and a1 is 80 into 40, that is 3200. Next, similarly, the second section is a right angle triangle whose uh, whose area is simply half BH. Now its base is 80 and its height is 20 for the section 2. So half into 80 into 20. So it is 800. A2 is 800. Now coming to the centroid, so now the x term is 2b by 3. Okay, so 2b by 3. Now the x term is 2b by 3, nothing but 2 into 80 by 3. Okay, 2 into 80 by 3. Now coming to the y term, see this triangle is situated at a distance of 40 from the x-axis. So you have to consider that distance also. So it is 20 by 3 plus 40. So 40 is the distance through which the axis and the uh, triangle are located. So 40 plus h by 3, nothing but 40 plus 20 by 3. Okay, so that is your y term. Next, semicircle. So for the semicircle, the area is pi r square by 2, nothing but pi into 40 square, pi into 20 square by 2. Now the x term is, see, the semicircle is situated at a distance of 40. So 40 plus d by 2, nothing but 40 by 2. 40 plus 40 by 2 is 60. Next, now if I want the y term, so the base lies on the x-axis only, so no distance is there. So here we can write simply 4r by 3 pi. So 4 into 20 by 3 pi is the y term. Okay? So like this we are going to find the centroids. So as the section is not symmetrical about any axis, so you need to find both x and y terms, and we know that we have divided that uh, uh, into the standard parts that are uh, those are a rectangle, a triangle and a semicircle. It is 80 by 40 and 80 and 20 and 20. Next we have taken that areas into multiples, and so a1 x1, a2 x2, a3 x3, and similarly a1 y1, a2 y2 and a3 y3, and summation of all those we have taken. Okay, so positions of the centroids also we have found. So now next problem, it is a semicircle of 90 radius is cut out from a trapezium. Okay, so this is a trapezium. From this a semicircle is removed. Find the centroid of the section. Okay, so now the semicircle is given. So its radius is 90 and it is placed in a 300. So now I can divide this centroid into 4 sections, right? Into 2 sections. One is a trapezium and one more is a semicircle. So, so a trapezium of base 300 and the height 200 and the shortest length is 120 and semicircle radius is of 90. Now the area of this is 120 into 500 by 2, h by 2 into a plus b. Okay, so h by 2 into y plus b is 120 into 500 by 2. So that will give you 30,000. Next, the y term is 56. So ay is 16 lakhs 80,000. Next, the area of that semicircle is pi r square by 2. Nothing but pi into 90 square by 2. So you will get a value of 4050 pi. But it is given that you need to remove that semicircle portion from the trapezium. So we will take minus. So minus pi r square by 2, it is minus 40, 50 pi. Now the y term is, it is 38.2. So we know that h by 3 into 2a plus b by a plus b is the formula for this particular centroid of a trapezium. So you'll get a value of 38.2 there. Now a1 y1 is equal to minus 48 4,000, sorry, 4,86,000. Now sum of the areas, that is minus 4050 pi plus 30,000. It will give you a value of 17,276.54. Next, a1 y1 minus a2 y2. It is 16,80,000 minus 4,86,000. So that will give you a value of 11,94,000. So this is how we calculate the trapezium for a centroid. Okay. Next, so y bar is equal to uh, sum of a1 y1 minus a2 y2 by sum of a1 plus a2, that is equal to 11,94,000 by 17,276.54. So that is equal to 69.1 mm. So this is how you'll get the values. So this is all for today. So we have discussed 4 different types of problems of composite figures, and we have learned that first we need to remove the uh, first we need to divide the given composite figure into our comfortable geometric section. Then we need to uh, denote the dimensions of the each section, and then after writing the dimensions of the each section, next we need to write the areas of each section, that is a1, a2 and a3, etc. The respective areas of the sections have to be noted down. Thereafter we need to write the mm, centroid of each section, that is based on its shape, whether it is a rectangle or a triangle. Their implied formula has to be substituted in that. Next, we need to find the a1 y1, a2 y2, a3 y3 and so on, a1 x1, a2 x2, a3 x3 and so on. And we have to find the summation of moment of areas about the x-axis and summation of moment of areas about the y-axis. Then after finding the centroid of the entire figure, it is simply x bar equal to a1 a sum of the ax, it is nothing but moment of inertia, by sum of the areas. Next is x y bar is equal to sum of the moment of areas about the x-axis by sum of the areas. So likewise, we are going to find the moment of inertia of all the things. So this is all what we have discussed today, and in tomorrow's class we'll be discussing about the uh, few more problems and perpendicular axis theorem and the parallel axis theorem. Okay, so uh, this is the class for today.